All right, welcome everybody. So in this video, we are going to go through an explicit example where we have a subspace W, which is a subspace of R3, which is spanned by two vectors U1 and U2. So U1 is the column vector 0, 3, 0, and U2 is the column vector -2, 0, 4. So this subspace that's spanned by these two vectors, that's this plane that I've sketched in R3 below, which is spanned by this vector U1, which is 0, 3, 0, and then U2 is this vector which is heading backwards a little bit by -2 units and then up by 4 units. And here's a vector y, which I've sketched in red, which is has coordinates, or y is the column vector -1, 3, and 6. So this is back 1 unit, 3 units to the forward, and then 6 units up. So that sits over here above the plane. And what we'd like to do is take this vector y and write it as a sum of two vectors. One of them is the orthogonal projection of this vector y onto the plane w. So that's this vector that I've drawn in black that we denote with y hat. So this vector y hat is going to sit in this plane. So what we need to do is find weights for u2 and u1 so that when we add those combinations of u1 and u2, we get this vector y hat, which is in the plane w. And then this vector over here, z, is the component of w, which is orthogonal to this subspace w. So by taking y hat and then adding this orthogonal component z, that gives us back the original vector y. So our goal here is to take this vector y, which is not in this plane, and write it as a sum of two vectors, one of which is in the plane and the other is perpendicular to the plane. So since our basis for this subspace W is orthogonal, then we can find the weight C1 by taking a look at this inner product of y with U1 divided by the inner product of U1 with itself. And so taking the inner product of y with U1, we would get 0 times -1 plus 3 times 3 plus 0 times 6. So that gives us a 9. And then taking the inner product of u1 with itself, we would get 0 squared plus 3 squared plus 0 squared. So that also gives us 9. So this first weight is going to be 9 divided by 9, which gives us 1. And then we do the same to find weight C2, except now we're going to take y inner product with u2 divided by the inner product of u2 with itself. And I'll save the calculation there, but taking the inner product of y with u2 gives us 26, and taking the product of u2 with itself, that gives us 20. So weight C2 is 13/10. And all of these calculations are done in the Colab notebook, which is linked in the description to this video below. So now that we have our weights, we're ready to compute y hat. We're ready to find this projection of y into the subspace W. So I'm going to use 1 times u1 since the weight C1 was equal to 1. And then we're going to take 13/10 and multiply that by u2, where this weight 13/10 comes from this calculation here. So we take 1 times u1 plus 13/10 times u2, which was the vector -2, 0, 4. And then we simplify. You could check this in the Colab notebook. This simplifies to -13 fifths, 3, 26 fifths. So this vector is sitting right here in this green subspace W. And then to find what the orthogonal component z is, we just take our vector y and we subtract y hat from it, and that's going to give us this missing piece. So the subtraction of these two vectors, here was the vector y that we started with, -1, 3, 6. Here was the projection that we just found, y hat, which was -13 fifths, 3, 26 fifths, and subtracting these two vectors gives us vector z, which is 8/5, 0, 4/5. And you can see that this vector has no component in the x2 direction. Okay, so that wraps up this example. Again, we had a vector y, which was starting outside of this subspace W, and the goal here was to take y and write it as a sum of a vector y hat, the projection into the plane W, plus a component which is orthogonal to W. And again, if you want to check any of these calculations, check out the Colab notebook linked in the description of this video.